In this video, we will be talking about how to solve radical equations. So there are 4 steps to solving radical equations. You're going to get the radical on one side of the equation, so you're going to isolate it. You're going to take each side of the equation to the power of the index to get rid of the radical. You're going to solve the equation that's left, and then you got to make sure you're checking for extraneous solutions, because sometimes extraneous solutions happen and they don't actually work. So we will be doing the odds in this video. The evens will be left to you as practice. So first we need to isolate. So we want the radical by itself, so I'm going to subtract 5. So I have the square root of x equals 7. And I want to undo the square root, so I'm going to square both sides. So I have x equals 49. So let's check that. So square root of 49 plus 5 equals 12. Well, the square root of 49 is 7 plus 5 equals 12. So yes, it works. So x equals 49 is the solution. 3. I'm going to subtract 10. So I have the square root of a plus 7, there's where the 7 came from, equals 1. So what I want to do is I want to get rid of the square root, so I'm going to square both sides. 1 squared is 1, and then this becomes a plus 7, and it's nice and easy to solve. So a equals 6. Wow, I can't even do basic math tonight. -6. Let's make sure that works. Check. 10 plus square root of -6 plus 7 equals 11, potentially. So -6 plus 7 gives me 1. Square root of 1 plus 10 is 11. Cool, it works out. Alright, 5. So I still want to isolate this thing, so I'm going to take it and divide it by -9 on both sides. So this gives me a 4, and this gives me c minus 12 to the 1/2. And so I'm going to take both sides and square it, because what undoes 1/2 was squaring. So I get 16 equals c minus 12. I'm going to add 12, so c equals 28. Let's check it. So I have -36, potentially equals -9 times 28 minus 12 to the 1/2. So -36 equals -9 times 16 to the 1/2. Well, 16 to the 1/2 is 4. -9 times 4 does in fact equal -36. So it works. So 28 is the solution. If you get one solution and you check it and it doesn't work, the answer is no solution. Alright, so 7 here. I have the 4th root of 8k plus 12 minus 9 equals -11. So I'm going to add 9 because it's not under my radical. So I have the 4th root of 8k plus 12 equals -2. So I'm going to take the 4th root of both of them. Take it to the 4th power, not the 4th root. It undoes the 4th root. So 8k plus 12. I'm going to write it a little bit nicer. 8k plus 12 equals 16. So now I'm going to solve for k. Alright, let's check it. Let's see if k actually equals 1/2. The 4th root of 8 times 1/2 plus 12. That's all under my root, and then I subtract 9 equals -11 potentially. So I have the 4th root of 4 plus 12 minus 9 potentially equals negative 11. So the fourth root of 16, which is 2, minus 9 equals negative 11. So 2 minus 9 does not equal negative 11. So this doesn't work, so we have no solution. No solution in this case. And that's okay, we're allowed to have no solution. It's fine. Alright, moving right along, let's do number 9. So I have u minus 8 equals the square root of u minus 8 equals the square root of 43 minus 2u. So I don't have anything to isolate here, I'm just going to square both sides. So I have u minus 8 equals 43 minus 2u. And when you solve this, for u, you get 3u equals 51. So u is going to be potentially 17, if it works out nicely. So what I'm going to do is I'm going to do my check, and you're going to plug it in both places where u exists. The square root of 17 minus 8 potentially equals the square root of 43 minus 2 times 17. So 17 minus 8 is 9. And then 43 minus 2 times the square root of 17 is 9. So 3 equals 3. So it checks out, and 17 is the solution. $11 is lovely, just lovely, because I need to isolate things. So, I need to isolate my radical, but let's divide this by 4 to try to get that to go away. So, those 4s are going to go away, and I have 3q plus 15, and then 12 divided by 4 becomes 3, and then I can't get rid of that radical quite yet. So, how do I get rid of my radicals? My square roots, I'm going to square both sides. So I have 3q plus 15 equals, and then 9q. Because you got to square the 3 as well. And solving, you get 15 equals 6q. So q is 5 halves when you simplify. Alright, so let's plug it in. Let's check this thing. 4 times the square root of, I'll just go ahead, 15 halves plus 15 equals 12 times 5 halves. 4 times the square root of 45 halves equals 12 times the square root of 5 halves. 45 breaks into 5 and 9, and 9 comes out, so I get 12 square roots of 5 halves, not 3. 5 halves equals 12 square roots of 5 halves. That's all you need to do, so it works. Excuse me. Alright, 13. So now I have a radical on one side and a variable, just a variable on the other without radicals. So what I'm going to do is I'm going to square both sides, because the radical is already by itself, it's hanging out. So I have 8x equals x squared. So what I'm going to do is I'm going to subtract the 8x over, so I have 0 equals x squared minus 8x, and I'm going to factor this. The greatest common factor is an x, so I can take out x minus 8, have that equal to 0, solve, x equals 0, and x minus 8 equals 0, so x equals 8. So 0 and 8 are potentially solutions, and you got to check both of them. So square root of 8 times 0 equals 0. Oh yeah, square root of 0 equals 0 all the time. So that one's the solution. Let's check the other one. Square root 8 times 8 equals 8. Yes, square root of 64 equals 8. So both of those are solutions. Alright, 15. So this one gets a little more complicated because I don't just have an x, I have an m minus 5. But I'm still going to square both sides. But when I do this, I'm going to have to write that m minus 5 twice and FOIL it. So I get 6m minus 38 equals m minus 5, m minus 5. And when I FOIL it, I get m squared minus 10m plus 25. Then 6m minus 38. I'm going to put everything on one side, so I'm going to subtract the 6m and add the 38. And when I do this, I get 0 equals m squared minus 16m plus 63. And when I factor this, what multiplies to 63 and adds to negative 16? Well, negative 7 and negative 9. M minus 7, m minus 9, 0 equals, well, so m equals either 7 or 9 potentially, and let's make sure. So let's check it. Square root of 6 times 7 minus 38 equals 7 minus 5. 6 times 7, 42 minus 38, and 7 minus 5 is 2. So I have the square root of 4 equals 2. That works all the time, so this one's a solution. Let's check the other one. The square root of 6 times 9 minus 38 equals 9 minus 5. Well, 9 minus 5 is 4. 6 times 9 is 54. Minus 38 is 16, which is 4. The square root of that is 4. So they both work. Sometimes you'll have ones that one works and one doesn't work, or neither of them work. It's okay. Just check them. Alright, last but not least. Very similar to 15. So we're going to square both sides. And I'm going to have 51 minus 5y equals y minus 11 times y minus 11. And when I FOIL that thing, I get y squared minus 22y plus 121. So I'm going to move everything to one side, so I have y squared minus 17y plus 70. And so what multiplies to 70 and adds to negative 17? 10 and 7, but both of them are negative. So 0 equals y minus 10, y minus 7. So y equals 10 and y equals 7 potentially. So let's check. Check, check, check. So square root of 51 minus 5 times 10 equals 10 minus 11. Well, I have the square root of 1 because 51 times 5 times 10 is 51 minus 50. And then equals 10 minus 11 is negative 1, so that's not going to work. So 10 is not a solution. And then I have 51 minus 5 times 7 equals 7 minus 11. Well, 7 minus 11 is negative 4. And 51 minus 35 gives me 16. But that's not negative 4, that's 4. So neither one of these work, and we have no solution. how you solve radical equations.